Hello students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is solving quadratic inequalities using the algebraic method. This is part 1. We will be having 2 video sessions on this particular topic. This is the first session. Okay, and actually these are continuous sessions, so every session will be assuming that you have the prior knowledge on inequalities, which may be obtained by watching my previous videos on this topic, the inequalities. Okay, and related to solving quadratic inequalities, I would like to say that there are several popular methods for solving quadratic inequalities, and I will try to explain each of those popular methods, and it will be up to you to decide which one to follow while solving questions on quadratic inequalities. Okay, so let's start and stay tuned till the end. I will be giving you the rules and I'll be explaining how to execute the rules by taking up a particular example. Okay, so first of all, let us take up that question. The question is solve 8 less than 5x square minus 6x. Now this is a quadratic inequality because the highest power of x is 2. Okay, now let us move on to the rules. The first rule says bring all the terms to one side of the inequality sign, the other side should have a 0. Now we can bring this 8 to this side, or we can take these two terms to the side of 8. But I always prefer to have the term containing x squared as a positive term. So I'll be bringing this 8 to this side. Okay, and it becomes like this: 5x squared minus 6x minus 8 is greater than 0. Now I have seen many students getting confused with these two statements. Over here the first one says that 8 is less than, we are having this less than sign over here, and this is the greater than sign. But they actually mean the same, because you see the opening side of this inequality is facing the 5x squared. In the original question, the 5x squared minus 6x was written on the right side, and now they are written on the left hand side of the inequality sign. But even now the opening side is facing towards the 5x squared minus 6x. These two terms. Okay, you have to just be careful that the opening side doesn't change the direction. Okay, because the opening side is facing towards 5x squared minus 6x in the original question, it should be continuing to face these two terms, 5x squared minus 6x. Okay, so we have brought all the terms to one side of the inequality sign, and the other side is having a 0. Coming to the second rule, factorize the expression, and we have to factorize this expression. I have factorized this expression using the middle term splitting method, but I am not going into the details of the middle term splitting method. I am assuming that you know the method, and this is the factorized form: x minus 2 times 5x plus 4 is greater than 0. We are having two linear factors, and the product of these two linear factors is greater than 0. That means the product will be a positive number. Okay. The third rule: if the question contains a greater than or equal to, like over here, inequality, then either both the linear factors will be greater than or equal to. If you have this equality sign in this particular question, we are not having this equality sign, but you can have the equality sign as well. Okay, so if it is greater than or equal to 0, then either both the linear factors will be greater than 0, or both will be less than 0, because their product is greater than 0. Because let me take up an example, two numbers. Suppose 12 is greater than 0. Of course 12 is greater than 0. How can we get 12? We can get 12 by multiplying 3 and 4. 3 times 4 is 12. So 3 is positive, 4 is positive. If we multiply these two positive numbers, we get a positive product. Or else we can multiply negative 3 with negative 4. Even then we get a positive product, that is positive 12. So we get the product of positive 12 if we multiply two positive numbers 3 and 4, and also if we multiply two negative numbers negative 3 and negative 4. That is what is said in this rule number 3. Okay, so either these two linear factors both will be greater than 0 or both will be less than 0. Okay, so either x minus 2 is greater than 0 and 5x plus 4 is greater than 0, or x minus 2 is less than 0 and 5x plus 4 is less than 0. Okay. Rule number 4. Solve the two factors separately for both the cases. Both the cases means these two, either and or, and take one inequality that satisfies both the inequalities from each case. That means we will be taking one result from this either part and another result from this or part if possible. Now for this particular question, we can take, you will be seeing that we will be able to take two results from one from each part. But in our next session, you will be seeing there will be a case in which you will not be able to take one result from each part. Okay, that is why it is written if possible. It is not possible every time. Okay, but for this particular question, we can take one result from each part. So now let us solve these. X minus 2 is greater than 0 means x is greater than 2. And 5x plus 4 is greater than 0 means x is greater than negative 4 over 5. And we have to take a single inequality out of these two inequalities, which will be satisfying both these two inequalities. Let us start with x is greater than negative 4 over 5. If x is equal to 0, if we take the value of x to be equal to 0, then 0 is definitely greater than negative 4 over 5. But 0 is not greater than 2. So if we take this inequality that x is greater than negative 4 over 5, we will be having some values of x which will not be satisfying this inequality x is greater than 2. But if we take this inequality x is greater than 2, suppose x is equal to 3, 3 is greater than 2 and 3 is also greater than negative 4 over 5. Any number which is greater than 2 will also be greater than negative 4 over 5. So we will be taking this x is greater than 2 to represent both these inequalities. Okay, coming to the or part. X minus 2 is less than 0, so x is less than 2 and 5x plus 4 is less than 0 gives us x is less than negative 4 over 5. So x is less than 2. Suppose that we take the value of x as 1. 1 is less than 2. But is 1 less than negative 4 over 5? Definitely not. So we cannot take this inequality to represent both these inequalities. We cannot take x is less than 2 to represent both these inequalities. We have to take x is less than negative 4 over 5. If x value is negative 1, negative 1 is definitely less than negative 4 over 5. And negative 1 is also less than positive 2. So in this case, we will be selecting x is less than negative 4 over 5 as the single inequality which will be representing both these inequalities. Okay. Now that we have got these two inequalities, we will be combining them to give the final answer. Combining them doesn't mean that you will be getting a continuous region. You may get a continuous region, you may not get. Like in this case, you cannot have a value for x which will be simultaneously less than negative 4 over 5 and greater than 2. It is not possible. x less than negative 4 over 5 implies x will be a negative number, and x greater than 2 will implies that x is a positive number. So this implies a negative number, this implies a positive number, both cannot be satisfied simultaneously. So either x will be a negative number which will be less than negative 4 over 5, or x will be a positive number which will be greater than 2. These two are two discontinuous regions which satisfy the given inequality 8 is less than 5x square minus 6x. This is our final answer. Okay? Students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.